Okay, so today what we're going to look at is the properties of matter. So specifically, what is chemistry? Well, chemistry is the study of matter and its changes. So matter, anything that has mass and takes up space. And what we're going to look at today is specifically the changes that it overcomes. So we are going to be looking at the various changes that matter undergoes, which is chemistry. So we have both physical and chemical things that occur to matter. Okay, the first we're going to look at is the physical. So there are both physical properties and physical changes. Okay, physical properties are defined as characteristics that do not involve a change in the sample's makeup. So what do I mean by that? Well, it basically says is that what you start with is what you end with. Okay, so you're not making any new compound, nothing is changing with respect to the chemical makeup of your substance. So these are things like the melting point. So if you think about an ice cube, when it goes from a solid to a liquid, it is at a specific temperature, and we've talked about the various temperature scales. You know for water, or H2O, that it goes from a solid to a liquid, or the other way around, at 0 degrees C, at 273.15 K, or at 32 degrees Fahrenheit. Okay, now, this does not involve the changing of the chemical substance. When you go from an ice cube to a puddle of water, it's still H2O. You simply have just changed the phase with which you are in, which is something that we'll talk about a little bit later. But you still have the exact same H2O. You haven't changed any of the chemical makeup. So that is what a physical characteristic involves. Solubility, odor, hardness, density, temperature, electrical conductivity, all of these things result in changes to matter, but not changes that involve something that occurs with the chemical makeup. Now, physical change, when, again, we have a substance alters its physical form, okay, not its composition. So, again, what you start out with is what you end with. So if you start with H2O and you test the temperature of it, it's still H2O. Okay. Now, chemical things such as property and changes, they do involve the change in the sample's chemical makeup. So what you start with is not what you end with. Okay, so we have things like rusting, combustion, tarnishing. These types of things are a result of a change in the chemical makeup. This is what's known as a chemical change. So we end up having the formation of new chemical compounds. So because this is happening, we know that there has to be the making and breaking of bonds between atoms. So on the first day of class, we did the example with the balloons, and I blew up the balloons. And that involved hydrogen gas, and we also had some oxygen gas. And what it produced was water vapor. So in this, and this is not a balanced formula right here, we would have to put a 2 here and a 2 here. So in looking at this, what we can see is that what we start with is not what we end with. Okay, H2 and O2 are definitely not water vapor. So this is a result of a chemical change, and this is a chemical reaction. So what we start with is not what we end with. Now, in addition, this is also what's known as a combustion reaction. And how we know it's a combustion reaction is because it contains oxygen. Okay? So combustion reactions, whenever you see a reaction that has oxygen, it's considered to be a combustion reaction. Now, a few additional things that we do need to discuss. These are what's known as intensive and extensive properties. Okay? Now, intensive properties, they are not dependent on the sample size. So things like temperature, color, melting point, boiling point, you know this is when we go from solid to liquid, liquid to gas, and also hardness. So if I say I put a thermometer in a beaker of water and it's 25 degrees C, I can also put a thermometer in a lake and it can be 25 degrees C. So it's independent of the sample size. Now, extensive properties, on the other hand, they are dependent on the sample size. So those are things like length, volume, height, mass, okay, where we have to specifically pay attention to how much of the sample is present. Okay, so if you think about the length of the desk in Clark 101, if I took a measurement and determined the length of it, we said, oh, it was 25 feet. Now, if I chopped it in half, obviously that measurement would change. So we absolutely have to pay attention to the amount of substance present in some cases, but sometimes we do not. And these are what's known as intensive and extensive properties. Now, if we continue, we want to talk about the various phases of matter. Okay, and these should be very familiar to you. This is something that you guys have talked about probably since you started science classes when you were in school. So, for the phases of matter in this particular course, we have solid, liquid, and gas. And these three phases are what we are going to study throughout the semester. So we are going to look at the various phases of matter, solid, liquid, or gas, and the changes that occur to them. So whether they be physical changes or whether they be chemical changes. Now, a solid is defined as having a fixed shape that does not conform to the container shape, meaning it has a definite volume and it has a definite shape. So, it does not take the shape of its container. Now, why is that? Well, it basically comes down to is the molecules themselves. Okay? So, the desk you're sitting in, it is considered to be a solid, but it's considered to be a solid because of how the molecules are arranged. The molecules themselves are very close together. They're touching. Okay? And we consider this to be what's known as tightly packed. Okay? Now, because they are so close to one another, they can't readily move around. There's not a lot of empty space. So, as a result, it ends up having this fixed shape that does not conform to the container shape. So it has a definite volume and definite shape. But it's because of how closely packed the molecules are. Now, one other thing about the solid is that it's not compressible, meaning we can't squish a solid. No matter how much pressure we put, we can't squish a solid down. And the reason, again, comes down to what the molecules are doing. They're very tight together. There's not a lot of empty space. So as a result of that, we can't squish that empty space out. So a solid is considered to be non-compressible. Now, the second phase of matter is a liquid. So a liquid conforms to the container shape, but it fills only to the extent of the liquid's own volume. So it has a definite volume, but not a definite shape. Now, again, the reason for this is because of the molecules. The molecules in a liquid are close together. They could be touching, but they could not be. So they can actually flow quite well around each other. They move around. So there is more empty space within a liquid than there is with a solid. And the molecules, they're close, but not as close as a solid. So there's more movement. Now, in terms of compressibility, because there's more empty space, you can compress a liquid slightly. You can squish out that empty space using pressure. However, it's essentially considered to be not compressible because you have to use such high pressures that it's really not worth using such a high pressure to get out such a little volume of empty space. So overall, we consider liquids to be non-compressible, just like a solid. Okay. Now, the third phase of matter that we're going to discuss is what's known as a gas. So a gas has no definite volume and no definite shape. So it conforms to the container shape and it fills the entire container, which is actually quite good for us because if you consider the Earth, it's kind of one big container. So it's good that the oxygen that we breathe fills the entire container, because if it stayed on one half of the container and not the other, the people on the other side who had the oxygen would have a problem, considering the ones who didn't have oxygen. Okay? Now, why is this? It's because the molecules are widely spread apart and they can move freely. There's a lot of empty space. So a lot of empty space. Okay. And with this, they can move around, they can flow very readily. Okay, and as a result, gases are actually compressible, whereas liquids and solids are not compressible. And the reason is because there's a lot of empty space. We can apply a pressure, so that we can squish out that empty space. And if you think about grilling, if you use a propane tank, that propane tank has a lot of gas in it. Okay, and you use it and use it and use it, and it never kind of seems to run out. And the reason is because we've taken propane and we've squished out all of that extra empty space. So what it is the whole bunch of straight propane in your tank. So even though you have a ton of gas in that tiny little tank, okay, it's because we were able to compress it down. Now, just to give you a visual of what we see here and what the molecules look like, we see that with the solid, they are very close together, tightly packed. They can't flow around. They're not compressible. A liquid, the molecules, they're further apart. They can flow a little bit more. There's more empty space there. And then with the gas, we have a lot of empty space. And as a result, we see our molecules not having any definite volume, not having any definite shape. Now, just to give you a visual, one thing you should be very familiar with, H2O. H2O you guys have seen in all three phases. We've got our solid phase as an ice cube where the molecules are very close together. We have our liquid phase where we see that the molecules are a little bit further apart. They can flow over past one another. And then we have water vapor, which is our gas, where we have a lot of empty space. Okay, so these are the three different phases of matter. Chili also represents the three phases of matter quite well as well. So we have what is chemistry, the study of matter and its changes. And we know those changes can either be physical, which result in no change to the substance, so what we start with is what we end with, or they could be chemical, which results in the making and breaking of bonds, and what we start with is not what we end with. And we also have the three phases of matter, solid, liquid, and gas, and they are solid, liquid, and gas due to how their molecules are arranged. And these three phases of matter are what we're going to look at throughout the semester, in addition to the changes that occur to them.